Exploring the Red Planet, 20 Years of Mars Rovers and Their Impact on Space Exploration. Overview. The exploration of Mars has undergone a remarkable transformation over the past 2 decades, primarily due to the advancement of robotic rovers. Notably, NASA's Spirit and Opportunity rovers, which landed on the Martian surface in January 2004, have played a pivotal role in enhancing our understanding of the Red Planet. This report chronicles the significant milestones in Mars rover exploration and examines their profound impact on space science and education. Timeline of key events. 1997, NASA's Sojourner becomes the first successful rover to land on Mars, providing valuable insights into the feasibility of mobile exploration on another planet. 2004, Spirit and Opportunity land on Mars on January 3 and January 24, respectively. Their mission focuses on searching for evidence of past water on Mars, marking a crucial step in understanding the planet's geological history. 2012, the Curiosity rover, equipped with advanced technologies, lands on Mars using an innovative sky crane and embarks on a mission to investigate the planet's habitability. 2021, the Perseverance rover lands in Zhurong crater, tasked with collecting rock samples for eventual return to Earth. This mission aims to search for signs of ancient life. 2021, Zhurong, China's Mars rover successfully lands on the planet, marking a significant milestone in international space exploration efforts. Impact and findings. The contributions of Spirit and Opportunity have been groundbreaking. Both rovers provided critical evidence confirming Mars' watery past. Opportunity's discovery of hematite blueberries and Spirit's identification of ancient hot springs were essential in demonstrating that liquid water once existed on the Martian surface. These discoveries set the stage for more advanced missions, including Curiosity's exploration of ancient lakes and Perseverance's current efforts to gather samples for future analyses. Technological progression. The evolution of Mars rovers reflects a trajectory of increasing complexity and capability. Sojourner, the first rover about the size of a microwave oven, operated with limited mobility and autonomy but successfully demonstrated the potential for robotic exploration on Mars. Spirit and Opportunity, each the size of a golf cart, these rovers greatly exceeded their expected lifetimes, with Opportunity operating for nearly 15 years. They showcased advancements in durability and scientific instrumentation, enabling them to conduct extensive geological surveys. Curiosity, this SUV-sized rover, introduced sophisticated scientific instruments and autonomous navigation, allowing it to traverse diverse terrains and conduct in-depth analyses of Martian rocks and soil. Perseverance, building on Curiosity's legacy, Perseverance is designed to collect and cache rock samples, utilizing advanced autonomous capabilities to navigate Martian landscapes effectively. International participation. The landscape of Mars exploration has broadened with the successful landing of China's Zhurong rover, which has discovered signs of recent water activity in a younger geological context. This achievement emphasizes the increasing global collaboration and competition in the field of planetary exploration. Educational and inspirational legacy. The Red Rover Goes to Mars program, initiated by NASA in collaboration with the Planetary Society, has significantly engaged students worldwide, fostering interest in space science. Notable participants such as Abigail Freeman and Courtney Dressing have gone on to achieve successful careers in planetary science, exemplifying the program's impact on inspiring future generations. Common themes and differences. The overarching theme across various sources is the transformative nature of Mars rover missions, particularly in confirming the presence of water on Mars and inspiring subsequent generations of scientists. However, differences arise in focus. NASA's official communications tend to emphasize technical achievements and scientific data, while articles from Science News and the Planetary Society highlight personal stories and the educational impacts of these missions. Conclusion. The 20-year journey of Mars rovers encapsulates a remarkable evolution in robotic exploration that has reshaped our understanding of Mars history and its potential for life. Each rover has contributed uniquely to our knowledge, paving the way for future explorations and inspiring new generations of scientists and engineers. As we look to the future, the legacy of these missions will continue to inspire curiosity and drive innovation in space exploration. References: 1. NASA 20 years after landing, How NASA's twin rovers changed Mars science, 2024. 2. Science News, How Mars rovers have evolved in 25 years of exploring the Red Planet, 2022. 3. The Planetary Society, Red Rover Goes to Mars. 20 years later, 2024. Counterintuitive information in the context of the Mars rover exploration includes: 1. Longevity versus expectations. While the Mars rovers were designed for short missions, 90 days for Spirit and Opportunity, they far exceeded expectations. Opportunity lasted nearly 15 years, which is counter to the typical expectations of mission duration in space exploration, suggesting that initial design parameters may not always predict actual performance. 2. Initial skepticism about roving. Before the success of Sojourner, there was significant uncertainty about the feasibility of deploying a mobile robot on Mars. This skepticism was rooted in the challenges of landing precision and communication, yet Sojourner's success paved the way for future missions, demonstrating that early doubts were not reflective of the potential for success in robotic exploration. 3. International competition as collaboration. The arrival of China's Zhurong rover signifies a shift from a primarily US-centric Mars exploration narrative to one that includes international participants. This suggests a growing collaborative spirit, contrasting with earlier views of space exploration as a competitive race among nations. For technological progression, the rovers show a steep trajectory of technological advancement where each successive rover greatly outperformed its predecessor. Curiosity and perseverance, for example, are not just larger and more complex, they also demonstrate significant improvements in autonomous navigation and scientific capabilities compared to the much smaller and less capable Sojourner. 5. Public engagement and inspiration. The impact of educational outreach programs like Red Rover Goes to Mars reveals an unexpected legacy. The program not only inspired future scientists but also highlighted the importance of public engagement in science. This suggests that the success of scientific missions is not solely based on technological prowess but also on their ability to inspire and educate the next generation. 6. Diversity of findings. The rovers have found evidence of various types of water environments on Mars over different geological periods rather than a singular wet phase. This complexity contradicts the simplified narrative that Mars was either wet or dry, highlighting a more nuanced understanding of its climatic history. 7. Rover personality and human connection. The anthropomorphizing of rovers, such as referring to Perseverance as a high-powered mid-career person, introduces an emotional connection to these machines. This humanization could be seen as counterintuitive to traditional views of robotic missions as merely mechanical endeavors. These points illustrate a richer and more complex narrative in Mars exploration than may be initially expected, emphasizing the interplay of technological, human, and scientific factors in the success of these missions. The report on the 20-year legacy of Mars rovers highlights numerous important aspects that many readers might overlook. Here are some of those points along with their significance. 1. Long-term durability of rovers. The longevity of the Spirit and Opportunity rovers, which were designed for just 90 days but operated for years longer, is often celebrated. However, the implications of this durability are significant. It showcases not only the technological advancements made in engineering but also provides critical data over extended periods. For instance, Opportunity's nearly 15-year mission allowed scientists to observe various geological formations and Martian weather patterns over time, offering insights into the planet's climate changes. The unexpected lifespan of these rovers fundamentally altered mission planning and expectations for future rovers, emphasizing the need for robust engineering that can withstand harsh environments. 2. Water evidence and its implications. The discovery of hematite blueberries by Opportunity and potential ancient hot springs by Spirit were pivotal in confirming the existence of liquid water on Mars. While the fact itself is often noted, the broader implications for astrobiology and the understanding of Mars as a potentially habitable world are immense. This evidence has shifted the scientific perspective on Mars from a barren wasteland to a planet that may have once supported life, influencing subsequent missions like Curiosity and Perseverance, which search for signs of past life and habitability. 3. Technological evolution. The report details the evolution from Sojourner to Perseverance, but the nuances of this technological progression are often understated. Each rover not only improved in size and capability but also in autonomy and decision-making. The introduction of autonomous navigation in Perseverance, which allows it to make decisions on the fly without waiting for instructions from Earth, is particularly significant. This technology paves the way for more complex missions in the future and reduces the communication delay issues that have historically hampered Mars exploration. 4. International collaboration and competition. The inclusion of China's Zhurong rover in the Mars exploration narrative marks an important shift in the landscape of space exploration. While this is often presented as a milestone, the implications for international collaboration and competition are profound. The success of Zhurong not only demonstrates China's growing capabilities in space exploration but also suggests a future where multiple nations may work together or compete on planetary missions, which could lead to shared knowledge or conflicts over lunar and Martian resources. 5. Educational impact and outreach. The Rover Goes to Mars program, which engaged students globally, highlights the importance of outreach and inspiring future generations. While many might see this as an ancillary benefit of the missions, it is crucial for the sustainability of interest in STEM fields. The report mentions that participants like Abigail Freeman and Courtney Dressing went on to have significant careers in planetary science, illustrating how direct engagement can shape future scientists and engineers. This emphasizes the need for ongoing educational initiatives in space science to cultivate a new generation of explorers. 6. Cultural reflections through rover names. The naming of the rover's Spirit and Opportunity conveys deeper cultural narratives that are easily overlooked. The names chosen reflect human values and aspirations, particularly in the context of exploration and discovery. This aspect humanizes the technology and creates a narrative that connects emotionally with the public, fostering a sense of shared journey between Earth and Mars. 7. Real-world applications of rover technology. The advanced technologies developed for Mars rovers, such as autonomous navigation and remote sensing instruments, have practical applications on Earth. These advancements can be applied in various fields, including disaster response, environmental monitoring, and even urban planning. The report may not emphasize this, but understanding the transferability of these technologies can help justify the investment in space exploration. 8. Climate change insights. The rovers have provided significant data on Martian climate, showing how its environment has changed over time. This data contributes not only to our understanding of Mars but can also offer comparative insights into Earth's climate change issues. The parallels drawn between the two planets can enhance scientific discussions around climate resilience and sustainability. 9. Public engagement and science communication. The emphasis on public engagement through initiatives like the Rover program sheds light on the importance of science communication. Many readers may underestimate how public interest can drive funding and support for continued exploration. The engagement of diverse communities in space missions can lead to broader public support and investment in science and technology. These overlooked elements emphasize that the exploration of Mars is not merely about scientific discovery but encompasses cultural, educational, and technological dimensions that impact humanity's broader understanding of life, the universe, and our place within it. Understanding these multifaceted impacts can inform future missions and inspire continued investment in space exploration. 1. Significant scientific discoveries. The Mars rovers, particularly Spirit and Opportunity, fundamentally shifted our understanding of the red planet, confirming the existence of past water. Opportunity's discovery of hematite blueberries and Spirit's evidence of ancient hot springs were pivotal in demonstrating that liquid water once flowed on Mars. These findings not only reshaped theories about Martian history but also laid the groundwork for future exploration, including Curiosity and Perseverance's missions focused on seeking signs of past life and habitability. 2. Technological evolution of rovers. The progression from Sojourner to Perseverance reflects a remarkable evolution in rover technology. Each new rover has built upon the successes and lessons learned from its predecessors. For example, the introduction of advanced instruments, autonomous navigation, and the innovative skycrane landing technique for Curiosity are milestones that represent significant advancements in engineering. Perseverance continues this trend, demonstrating enhanced mobility and efficiency in sample collection, showcasing the increasing complexity and capability of Mars exploration technology. 3. International collaboration and competition. The landscape of Mars exploration has expanded with the inclusion of international efforts, notably China's Zhurong rover. This development signifies a shift towards global collaboration and competition in space exploration. The successful landing of Zhurong, which found evidence of recent water activity, highlights the growing interest and investment in planetary exploration from multiple nations. This international participation enriches scientific discourse and fosters collaborative opportunities for future missions, emphasizing the shared human endeavor to understand Mars. 4. Educational and inspirational impact. The outreach initiatives associated with the Mars rover missions, particularly NASA's Rover Goes to Mars program, have had a profound impact on inspiring future generations of scientists and engineers. The personal stories of participants such as Abigail Freeman and Courtney Dressing illustrate how engagement with these missions can shape careers and ignite passion for space science. This emphasis on education and public engagement underscores the importance of fostering interest in STEM fields and highlights how space exploration can serve as a powerful catalyst for inspiring young minds globally. Here are 3 famous historical cases that are similar in theme to the exploration of Mars through robotic rovers, particularly in terms of technological advancement and scientific exploration. 1. The Apollo Moon missions 1961 to 1972. NASA's Apollo program aimed to land humans on the Moon and bring them safely back to Earth. The program culminated in Apollo 11, where astronauts Neil Armstrong and Buzz Aldrin made history as the first humans to set foot on the lunar surface on July 20. 1969, this program not only expanded our understanding of the Moon's geology but also demonstrated the capabilities of human space exploration, paving the way for future missions to other celestial bodies. The technological advancements developed during the Apollo missions, including new materials, computer technologies, and life support systems, influenced various fields and inspired generations of scientists and engineers. 2. The Voyager Golden Record 1977. The Voyager program launched 2 spacecraft, Voyager 1 and Voyager 2, in 1977 to explore the outer planets. Each spacecraft carried a phonograph record known as the Golden Record, which contains sounds and images intended to portray the diversity of life and culture on Earth. This initiative represented humanity's first attempt to communicate with potential extraterrestrial civilizations and marked a significant milestone in our exploration of the solar system. The Voyager missions provided invaluable data about the outer planets and their moons. And the Golden Record has become an enduring symbol of our desire to connect with the cosmos. 3. The Hubble Space Telescope 1990-present. Launched in 1990, the Hubble Space Telescope has revolutionized our understanding of the universe. Hubble has captured stunning images of distant galaxies, nebulae, and other celestial phenomena, leading to groundbreaking discoveries such as the acceleration of the universe's expansion. Like the Mars rovers, Hubble represents a significant technological achievement and has inspired a new generation of astronomers and space enthusiasts. The telescope has provided insights into the formation and evolution of galaxies, and its legacy continues to influence our understanding of astrophysics and cosmology. These historical cases like the Mars rover mission showcase the spirit of exploration, the advancement of technology, and the quest for knowledge that drives humanity to reach beyond our home planet. Future outlook, predictions for Mars exploration and rover technology. The exploration of Mars has entered a transformative era thanks to the achievements of a succession of robotic rovers over the past 20 years. As we look toward the future, several key predictions can be made regarding the direction of Mars exploration, advancements in rover technology, and the potential for human involvement. 1. Enhanced rover technology. The technological evolution of Mars rovers will continue to accelerate. Future rovers are likely to incorporate even more advanced artificial intelligence (AI) and machine learning capabilities, allowing for greater autonomy in navigation and decision-making. This will enable rovers to traverse complex terrains without the need for constant direction from mission control. The integration of AI could facilitate real-time data analysis, enabling rovers to adapt their exploration strategies based on immediate findings. Additionally, we can expect the development of smaller, more agile rovers equipped with advanced sensors, cameras, and scientific instruments. These new rovers will be capable of conducting more detailed analyses of Martian soil and rock samples, potentially identifying biosignatures or evidence of past life with unprecedented accuracy. 2. International collaboration and competition. The Mars exploration landscape is becoming increasingly internationalized, with countries like China, the United States, and potentially others actively participating in robotic missions. The success of China's Zhurong rover signifies a new era of global cooperation and competition in space exploration. Future missions will likely involve collaborations between different space agencies, sharing data and resources to maximize the scientific yield from Mars exploration. Moreover, as more nations develop their space capabilities, we may see a diversification of mission objectives. Countries could focus on specific scientific questions or technological challenges, leading to a richer understanding of Mars and its potential for life. 3. Mars sample return missions. One of the most anticipated endeavors is the Mars Sample Return (MSR) mission, which aims to bring Martian samples back to Earth for detailed analysis. NASA and the European Space Agency (ESA) have initiated plans to retrieve samples collected by the Perseverance rover. The success of these missions will pave the way for future sample return efforts, deepening our understanding of Mars geology and potential habitability. As MSR missions progress, we can anticipate the identification of specific locations on Mars that may harbor preserved evidence of past life. The findings from these missions could revolutionize our understanding of the planet while providing insights into the broader questions surrounding life beyond Earth. 4. Human exploration of Mars. The prospect of human exploration of Mars is becoming more tangible. NASA's Artemis program aims to return humans to the Moon as a stepping stone for future manned missions to Mars in the 2030s. These missions will likely rely on the technological advancements and knowledge gained from robotic missions. Future human missions to Mars will also focus on establishing a sustainable presence on the planet. This could involve the construction of habitats using Martian materials, in situ resource utilization (ISRU) for water and oxygen extraction, and advanced life support systems. The experiences garnered from rovers like Curiosity and Perseverance will inform habitat design and mission planning, ensuring that astronauts can safely conduct long-term studies on the Martian surface. 5. Public engagement and education. The legacy of educational programs like NASA's Rover Goes to Mars will continue to inspire new generations of scientists and engineers. As Mars exploration progresses, there will be an increasing emphasis on public engagement and involvement in space missions. This could involve more virtual participation opportunities, interactive educational tools, and citizen science initiatives, allowing enthusiasts and students to contribute to ongoing research. Future outreach programs will aim to engage a global audience, promoting diversity and equity in STEM fields and inspiring a new generation of explorers. As the missions become more complex, the need for public support and interest in space exploration will be crucial for securing funding and resources. 6. Addressing ethical and environmental considerations. As we advance our exploration efforts, ethical considerations regarding planetary protection will become increasingly important. The potential for contamination of Mars with Earth microbes raises concerns about preserving the Martian environment. Future missions will need to develop stringent protocols to minimize any biological contamination, ensuring that scientific findings are not compromised. Moreover, discussions surrounding the long-term implications of human presence on Mars will intensify. The potential for terraforming or altering Martian ecosystems must be approached with caution, weighing the benefits of exploration against the risks of disrupting an alien environment. Conclusion. The future of Mars exploration is filled with promise and potential. With advancements in rover technology, international collaboration, and the imminent prospect of human exploration, we stand on the brink of a new era in our quest to understand the Red Planet. The legacy of past missions will guide our efforts, while continuing engagement with the public will inspire future generations to reach for the stars. As we venture further into the cosmos, the discoveries made on Mars will undoubtedly reshape our understanding of life, our solar system, and our place in the universe.